Here, 5,500 years ago, with the advent of horse-drawn transport, brake pads and linings appeared. Here they brake, and when pressed down they brake with the shoes, because the horse couldn't cope on its own. After 3,000 years, a horseshoe appeared to prevent artiodactyls from slipping. This means that in ancient times in Georgia, such a braking device also appeared. When the bulls walk backwards, this log, it catches on the rocks, the road surface, and does not allow it to move down. But these mechanical braking systems, which were used both in horse-drawn vehicles and in cars, are based on friction in dry sliding. Here are two surfaces in contact. When one surface moves relative to the other, friction occurs here. Used in cars. At the same time, microcracks occur on the brake wheel disc, which grow into large cracks. In addition, heating occurs, which leads to the fact that the brake mechanism itself ceases to be controllable, since it overheats the pistons in the cylinders that are pressed against them, and they jam. As they say, it is usually caused by the brakes sticking. Is it dangerous? But besides this, if we talk about passenger aircraft, when braking, in addition to these negative effects, sulfur is released when braking. Sulfur 0.2 milliliters per cubic meter causes mucous membrane disease in children. The release of sulfur is also dangerous. Speaking about all the harms of the braking system, in 2020 in Oxford, March, the heads of the British company emission emitter said that it is 1,000 times worse than pollution from exhaust gases. It negatively affects the immune system, causes liver cancer, and so on. Nick Moden, the Director General of this company, points out that it is almost a black hole. In fact, they can't decide. Here we need to pay attention to our approach. We then came to the conclusion that what we do is synchronized with human inhibition. Imagine that the muscles here are like springs. Here are the rolling joints, the rolling support, the bearing. Here in our world and European patents and publications it is stated here that we use these two elements in order to decelerate, brake, stabilize speed and stop. The fact is that we have a brake disc. Springs are rigidly fixed around it, either on the shaft or on the disc. The other ends are adjacent to the inner ring of the bearing, which can move. Either move like this, or bend over. We'll show you about it. You can see what advantages have already been described here. We have patented in Georgia, Germany, 50 countries, the USA, China, India, and the European Patent Office. We searched under category A. These mechanisms look like this. In practice, we did this test for models, for industrial samples. And we then moved on to testing for electromagnetic braking. To get rid of the harmful electromagnetic braking, we used a mechanical braking device, which is based on elastic deformation according to Hooke's laws. Everything that we said here about creating a resistance force to a moving object was according to the law. They are almost similar, but here the force is normal pressure, and in this case the resulting resistance force depends on the deformation. This is Hooke's law, 6th grade school. In accordance with this law, we use this law to slow down, stabilize and stop our moving mechanism with any given acceleration. Everything here follows Hooke's law. Thanks to this law we have achieved the following success. The principle of braking is carried out according to the 3-in-1 principle. This is deceleration, stabilization of speed and stopping of a rotating shaft or vehicle. We demonstrated this using the example of electric motor braking. Here the operator must perform three functions. These are holding, emergency braking and braking. Here there is a broken graph, then the speeds change discretely. This is very important when it comes to holding some kind of load evenly or elevator, numerical control machines for medical or other equipment. With us, all this happens not along a broken line, but along a smooth one. Our acceleration and speed change smoothly. Everything is changing smoothly. We do not achieve discrete speed values, but smooth changes. It is very important. We can demonstrate all this on our models. I would like to emphasize one more point. When you asked whether our achievement of the braking device was related to the development of technology, I told you that it was not. Everything that was needed to create such a braking device existed 9,500 years ago. Elastic elements in the form of a bow for arrows, all sorts of tubes, wooden blocks from which you can make a bearing. It is noticeable that Leonardo da Vinci had such wooden bearings. Instead, we provide a comparison with this, how this could be done. Here the elastic is made on the wheel hub, or more precisely on the shaft, on the wheel rim. A disc is made on this shaft, and elastic elements are made from these rods on the disc. Then here are the bearings and bars. By pressing this you can achieve this effect. This is not about technology development. This is an idea, a new idea. Observation. How a person moves, how he stops. It does not use dry sliding friction. On the contrary, when synovial fluid runs out or decreases, pain begins in the joints. Therefore, here we are not talking about the need for some new technology. Here's the main idea. This does not depend on industrial enterprises, what resources they have, how rich they are, what equipment they have. For 5,500 years, nothing has changed yet. Pay attention to the modern paths. This is the development of modern technology. Nothing changed. Dry sliding friction also remains and the contact surface is also at risk, which leads to slipping in the event of moisture. The same thing is observed in conventional brake mechanisms on cars. When moisture gets in, it slips. But here, if such a mechanism was used, this process could naturally be avoided. The main thing is ideas. Here's my conclusion. This is perhaps one of the first prototypes that we tested. We tested the braking device. Using a motorcycle disc, we used the pads here. How they work and how our braking device works. Here we used such a mechanism. Let's turn it on. When we press, it stops, but we have to apply a lot of force. But at the same time, as we said, it throws out asbestos and dirt. This is known. Now we will stop using our braking device. We will demonstrate slowing down, stabilizing speed and stopping. Here we have elastic elements and a bearing. We slow down and stabilize the speed. We slow down and stabilize the speed. We can stop it abruptly. All three functions are performed by one lever. If you do it hydraulically by pressing the pedal, all this can be done. Therefore, there are no emissions and no noise effects. Note that there is a critical noise effect here. And there is no noise effect here. The rotating discs are mounted with rigidly fixed springs at one end. With their other free ends they are adjacent to the inner end of the bearing, which can move. It can be without a gap, it can be with a gap. In this case, we are experiencing a gap. Let's see. There is no distortion. The inner ring of the bearing rotates. We took the plate as the elastic element. This is a one-piece piece. There is a bearing inside that is adjacent to the inner ring. Now if we turn it on, they have a gap. Here we have no gap, and here with a gap. They rotate freely. When we restore and lower this lever, it is restored and rotates at some speed. This is a model. The bearing has rolling, but there is no friction or sliding. They move evenly along with this inner bearing race and create a drag force. And if we need to do it abruptly, we stop. Here, instead of springs, we made blades at an angle. These blades rotate to the right side, and there is also a bearing inside. By the way, the animation shows the bearing and how it interacts with these blades. You see, this is how the elastic ones press. And every next one that comes here, they have to pass this crotch in a pressed state. This creates a force of resistance. Let's check. He slows down, if need has to stop. This is a segment-based model. It demonstrates that this braking device can create any speed. Here, based on the latest model, in segments, we have made two in one. On the one hand, we have segments with bearings due to the movement of such a lever. On the other hand, we have an eccentric bearing, which, while rotating, is not located in the center, and due to movement, is pressed against these blades. For example, unlike electromagnetic braking, where we have engagement here, here we have pressing. This is an eccentric bearing. Here we show how it is slowed down by traditional braking, and here we show how at the expense of ours. You can also see this in the animated video. And now we are showing it live. First, when we turn on the engine, it has 3500 RPM, we can stop it. So we can set the speed, any speed, we can stop it abruptly without problems. And this, let's say, is an eccentric option. Here we have a bearing moving. This is 2-in-1. They are all suitable for electric generators and electric motors. In this case, if anyone is comparing, it is mechanical braking. He screams and squeaks. Yes, you still need to put in a lot of effort. And here we have such a stop. This is 2 in 1. They are all suitable for electric generators and electric motors. In this case, if anyone is comparing, it is mechanical braking. He screams and squeaks. Yes, you still need to put in a lot of effort. And here we have such a stop. They said that with electromagnetic braking there is a jump back. This is holding, this is emergency braking, this is braking as such. And the fact that the speed changes discretely and everything goes along a broken line. In our green brake, mechanical, not electromagnetic, everything goes smoothly. Acceleration changes smoothly. The operator can adjust all 3 functions with one press of the brake pedal. Both retention and stabilization of speed, which is not inherent in electromagnetic braking, and also a stop. And the speed can change smoothly, depending on the acceleration given by the operator. We will demonstrate all these 3 functions here too. Here on this model. This model is made of 2 discs. Discs with elastic plastic elements. Here is a motor with 3,500 RPM, corresponding to about 200 km per hour. There are elastic elements, metal, and bearings around it. Unlike the previous ones, for example, lateral movement, here this pedal rotates. This will be convenient for the operator. Rotation also occurs here. Here we have the rotation speed. And so, here we go. Set the speed. Here it corresponds to about 210 km per hour. As we said, we move the bearing, it has a gap, so the bearing does not rotate. This is an internal pulsar. We set at which the speed drops. And this speed can move. Pay attention to the speedometer, it can quickly stop it. And it can set the speed that we need. For example, the speed is 40 kilometers. This is very important when descending from Tospona mountain by wooden transport. It replaces both the retarder and the brake mechanism, everything. Now it's the same on the mechanical one. And here, as we said, there are other elements. It slows down here too. Pay attention to the speedometer. When we move the pedal, we see the speed that stops. He can do it abruptly, urgently. No problem. This model demonstrates our principle. 3 in 1. That is, slowing down, stabilizing speed and stopping. This is an innate sign of the presence of a living organism. This model, which is as close as possible to a living organism, demonstrates this.